Purdy. Okay, so like I said, we are going to start our study of ratios and proportional reasoning. Again, you did explore ratios in 6th grade. This is on page 83 in volume 1. Okay, so again, you can get this on Pearson. In Google Classroom, it's for the very first assignment or material link in Google Classroom. It says Student Accessible Edition or something like that, and then you can find the pages as you go. So we're going to just start off with some vocabulary and start off with some ratios just so we kind of get ourselves warmed up. So our vocabulary terms we're going to use: complex fraction, equivalent ratios, rate, ratio, and terms. Okay? So the first one, quantities x and y in the ratio xy are called, anyone have an idea?
Rate.
A rate, very good. Two dogs to 3 cats and 10 dogs to 15 cats are examples of
Ratios.
ratios. Are you sure?
Yeah. Equivalent? No, equivalent. Wouldn't it be equivalent ratio?
Okay, we'll look at 3 cats to 15 cats.
Yeah.
How do I get from 3 to 15?
Multiply by 5.
Okay, so 2 dogs to 10 dogs. How do I get from 2 to 10? Okay, now 2/3 is a fraction, right? 10/15 is a fraction. Are they equivalent fractions?
Yeah.
Okay, so that means that they are actually
Equivalent ratio.
equivalent ratios. Do baby hands freak you out? No. Baby hands don't freak you out? Just checking. I don't want to freak you out.
Can you imagine like getting in your bed and you
What, huh? Oh.
Can you imagine?
Okay.
Okay.
Uh-oh. This one should go down here.
Right.
This one goes up here. I don't know why ratio has the oh, no. Oh, God. We're horrible. Okay, the x and y. So we're only focused on the x and the y. Those are called the terms. Oh, Mrs. Sadik. Now, a rate is a type of ratio that has both terms expressed in different units. So, dogs to cats. That's a rate because it's expressed in different units. Okay, miles per hour. That's a rate that we use when we're talking about speed. Okay. Dollars per pound. Okay, we're comparing two things in different units. And the last one, a blank has a fraction in its numerator, denominator, or both.
Ratio. Complex fraction.
Complex fractions.
It says fraction, it's named something. Come on.
And we talked about complex fractions. Do you remember?
Nope.
Okay. We talked about complex fractions when we were dividing fractions. It looked like this. Fraction the numerator, fraction the denominator, and we know that this bar just means to divide. Okay? All right, now, equivalent ratios. Those are ratios that are equal. We can also say equivalent fractions. That might help us remember what that means. So, if we've got 4 boys to 7 girls, how do I get from 4 boys to 8 boys? Multiply by 2. So if I multiply 4 by 2, I also need to multiply 7 by 2. So 7 times 2 would be
14.
14 girls. So 16 tires to 4 cars is equal to blank tires on 1 car. How do I get from 1 to 4?
Divide by 4.
Divide by 4. So if I divide 4 by 4, I also need to divide.
16 by 4.
So how many tires in a car?
4.
All right, 8 correct out of 10 total. 8 correct out of 10 total. So how many would I get correct if if the total was out of 50?
40.
Okay, how do you know, Tucker?
Because you're multiplying by 5 between 10 and 50.
Very good.
And then 8 times 5 is 40.
Yep. So 10, to get to 10 to 5, we multiply by 5. So we also need to multiply 8 by 5, and that gives us 40.
This thing really likes 4s.
Oh yeah.
Pearson really likes, like you will see, because you're going to have Pearson for a long time, like, every answer's 2. Or every answer is 1.5 or something. I mean, they just, it's very hard for them to get out of their numbers, but
7
we see it all the time. All right, so we're going to focus today on ratios, rates, and unit rates. Okay, so okay, unit rate. The root word of unit is uni. Okay, very good. 1. Right? 1 horn, right? It looks like a piece of corn. Unicorn? No? Okay, all right, never mind. Right? Okay, what about this? C-Y-U-C. Oh. What did I tell you from the beginning? I can't do what?
You are mean.
No, I meant like everything in
Wow, that's
right. Alright?
I'll remember that for the rest of my life, Tucker.
Sorry, but I can't.
Tucker thinks I can do nothing.
At all.
But I'm talking.
Dude, what am I literally, what am I doing right now?
Having a kid.
I'm growing a child right now. Maybe I can't do anything. And I've grown 2 others.
And you're doing math right now.
Come on.
It's like the
Tucker.
different break.
that is like the rudest thing to say.
Unibrow, right? Okay, so unit. Okay, so uni. We see this over and over again. Uni, or that's always 1. Okay, so unit rate is going to have something to do with 1. Okay, so when we are looking at unit rate, we're looking for a denominator. Oh, God. Tour of. I'm not helping my cause with Tucker right now, right? Okay, unit rate, denominator of 1. Okay, so if I am talking about the price per pound, okay, so let's say at the grocery store, I want to go to the deli counter, and right now turkey is $4.99 per pound. Okay, that is a unit rate because it is 1, we're paying for how many pounds? 1. Okay, right now, gasoline okay, $2.27 for 1 gallon. Okay. Do you know how much it was before?
That's a very expensive gas. That's very expensive gas.
When I,
Extremely expensive.
in 2010-ish,
$5 a gallon.
it was like we were up at $3.99, $4 per
That's
gallon.
very
Yeah.
expensive.
Yeah, it was horrible. Okay? Now these are unit rates. Okay, now I drive big car, right? You guys know what kind of car I drive?
Nope.
Anyone know?
I do.
I drive a huge no.
Hummer?
No. I drive it's a
Huge white van.
it's a silver huge SUV. It's a silver SUV that's right out here in the parking lot, right? Mr. Fox's car is the maroon Taurus. Mr. Odie's car is the silver minivan. My car's right in the middle by the light pole, right? It's big. Huge gas tank. Filled up yesterday when I came to school. Because I didn't have any gas in my car. My brother-in-law Nick took my car all the way to the east side of Cleveland to pick up a Versa Climber. The thing LeBron loves. And he needed my car because my car's big. He didn't put any gas in it.
So it died.
I was really mad. So I got in my car and I was like, oh man, I'm going to have to put gas in my car. I made it here fine on Monday. Tuesday I was all right. Wednesday I was like, oh, the check gas light went on, so I had to fill up my car yesterday. Big car, right? So, this is how much it cost to fill up my car yesterday.
$90? It costs my dad like.
And then I put
I
in,
could buy the world with that money.
how much did I put in?
Probably like
$70 one.
Where did you go get gas? Did you go to like some fancy?
My brother's like,
No, well,
You put 50 gallons of gas in your car. How would you be able to? I could buy the whole world with that money.
okay, so I put about 28 gallons in my car yesterday. I have a big car, so I need a big gas tank, right? In my car, I need the premium gasoline.
Oh, that's expensive.
Okay? So, this is not a unit rate, correct? Okay, because this is not per one unit, this is per 28 units. So this is an example of a rate.
That just looks like a base division problem.
A what?
That just looks like a regular division problem.
It is kind of like a rate. It's a fraction, right? So what we're trying to do, what we're going to focus on is getting our unit rate, or getting our rate to 1. Okay? So, if I know, let's do this.
Cold.
Yep, she's gonna call it. She plagiarized. She went.
Alright, who's gonna come to the office? I feel like that price is like
Oh, she's going to jail.
Are you
Play
ready?
Josie.
I'm trying to tell me how beautiful I look today, right?
Imagine
How
if
great I am. Now, I want, kids, what did I actually do? Did I mark everyone, I marked them, I just didn't. So thank you for calling me, telling me how great I look. Bye.
No, what?
imagine she actually did.
How much you spend What's wrong? Roughly
Okay, so this is a rate, right? But we want to focus right now on unit rate. Everything comes back down to the unit rate. So I don't want to know how much 28 gallons cost. I want to know how much 1 gallon costs. Okay? So, how do I get from 28 to 1? Not 28 divided by 1.
$90.58 by 28.
Listen to what I'm saying. How do I get from 28 to 1?
28 divided by 28.
28 divided by 28. A number divided by itself is always 1. So I need to divide 28 by 28 to get to 1. If I divide 28 by 28, I also need to divide, very good, Okay? Whatever you do to the bottom, you have to do to the to make the fractions equivalent. Very good. So this is how I go from a rate to a unit rate. Now this is why you need your calculators, because I'm not expecting you to divide $90.58 by 28. Okay? That's where your calculators come in handy. So I type in $90.58. Oops. Divided by 28.
$3.20.
Okay, so about 24 cents, right? So that means what to you?
That's how much
Premium gasoline.
Okay, so yesterday that's how much I paid for the gasoline that I put in my car
It's expensive.
for only 1 gallon. Okay, so again, this is your rate, and this is your unit rate. This is your home base. Okay? You can get anywhere if you can get back home. Right? Okay? So as long as you can get back home to 1, you can figure out how much 5 gallons is going to cost you, or 10 gallons is going to cost you, or 250 gallons is going to cost you. As long as you can get back to 1, you can go anywhere from 1. So this is our home base. This is where we're always going to go before we go anywhere else when we work with ratios. Okay. All right. So turn to page 86. Okay, so this is on page 86. Now, when you're working in your Pearson books, it gives you a lot of stuff. Okay? I don't give you as much stuff when we're working on a slideshow, right? Right? So, Nathan and Dan were both hired as lifeguards for the summer. They received their paychecks for the first week. Who earns more per hour? Okay? So who earns more? Here's Dan's paycheck. He worked 9 hours and had a total earnings of $78.75. And Nathan worked 5 hours and he earned $46.25. So the first thing we want to do is we want to set these up as rates. Money always goes on top. Okay? So, for Dan, he made $78.75 for 9 hours. Okay, so here's our rate, $78.75 for 9 hours. What about Nathan?
Nathan was $46.25 for 5 hours.
Is that 46?
Yes.
And he worked 5 hours, right? Does this tell us how or who made more per hour?
No.
No, because we've got different
Hours.
hours. We have no idea. So when we have different hours, we're not comparing apples to apples. Okay. How we compare apples to apples is we get to 1 hour. And we get here to 1 hour. So how do I get from 9 hours to 1 hour? I divide by 9. So I'm going to divide the denominator by 9. And if I divide the denominator by 9, I need to divide your numerator. Now when we do that, we type it in exactly. 78.75 divided by 9. So in our calculators, 8.75. Okay, so $8.75 per hour. So we know how much Dan makes per hour. How are we gonna figure out how much Nathan makes per hour?
You have to
It's
divide.
gonna be like
No,
$2.
you can't do that.
Why, hon?
You have to end up dividing by 5 then.
Okay. So that's something you really need to be careful about. We're not dividing both of them by 9. Okay? 5 to 1. How do I get from 5 to 1? Divide by 5. So if I divide my denominator by 5, I'm also going to divide my numerator by 5.
$9.25.
Okay? So even before I did any math, I knew that Nathan made more than Dan. And the reason being is because 9 goes into 78, it only goes 8 times.
Yeah.
Because 9 would go into 81 9 times. But 5 goes into 46, 9 and change, because 9 goes into 45, 5 goes into 45 9 times. So I knew that because I used estimates. Okay? But I didn't know the exact, so that's why I have my calculator, and I can use my calculator to help me. So Nathan makes $9.25 an hour.
It's like when a contractor estimates how much something will cost.
Absolutely.
That's how they do it.
Okay, that's why when anyone ever had like flooring, tile, anything like new carpet, anything like that put in their house, okay, and someone comes in and they measure, and they say it's going to cost you about this much.
It's not the exact, they just give you a rough.
You're right, because they don't know. I mean, you might need more, you might need less. They just give you a rough estimate, right? But when you buy carpet or tiling or flooring, it's priced per square foot. So they figure out how many square foot you need to cover, and then they multiply it by, the cost of it. Real life application? Absolutely. Okay? This stuff, this entire chapter, or this entire topic, 2 and 3, most important things I could teach you as a math teacher. So as a 7th grade math teacher. Because that stuff you actually use every day. Okay? We're redoing our basement. Yeah. We only built a 3-bedroom house when we built our house. Baby needs a bedroom, right? So we got to redo our basement because we need some extra room in our house. So all my husband and I did before we actually started doing the basement is calculations. Drywall, flooring, paint calculations, and then we got to do the trim. That's all we did. And we had talked about, and it all came down to a unit rate. Because once we figured out the unit rate, how much it was per foot, how much it was per piece of wood, or whatever it was, then we just multiplied to get a rate. My husband was very thankful that I'm a math teacher. Right? The last time he bought flooring for the house, when we actually built the house, I said, okay, I want floor, I want carpet in the kids' room, I want hardwood in our room and in the living room and, all this stuff. My husband comes to me, I go to the house. Grayson was just born. We're dealing with everything with Grayson. I go to the house, and I walk into the kids' bedrooms, and I was like, there's hardwood in the kids' rooms. He goes, yeah, I overbought. And I was like, what do you mean you overbought? He's like, I think my math was wrong, and I had way too much flooring, so we're not going to buy carpet. We're just going to... Should have let me do the calculations, buddy. But he did all of it himself. I can't. Yeah.
I remember when.
Yeah. Sorry. Me too. But I thought it'd be nicer for the kids in their rooms, if they play in that, no, that didn't happen. That's all right.
But
I'd rather have.
I have a question.
Yes, dear.
If the child likes Charlie D'Amelio,
D'Amelio?
No, D'Amelio. Shut up.
Who's Charlie D'Amelio?
If the child likes Charlie D'Amelio,
Yeah.
She's the
Will
most
you be
famous
okay
person
with
in
that?
the world off of an app.
If you go to and people know her more than George Washington.
Well, who is it? What does she do?
She is TikTok.
Oh, jeez.
Does dance.
He does.
1 million likes.
All right.
she's a,
So, here's our next problem. Jennifer is also a lifeguard at the same pool. She earns $137.25 for 15 hours of lifeguarding. How much does Jennifer earn per hour? Okay, calculate that for me.
$2.
Okay, so she works the same pool, $137.25. And she works 15 hours. How much does she earn?
I messed up on our calculations. I need to review them.
Sure, getting money. If I was making that much money per hour, I'd be the richest man alive. They call me. They call me Ray Rice.
Too smart. I just want to make sure that
Mason, me and you.
Okay, yes,
Knock it
I
off
was
at
right.
prom. Harder than them.
Okay, so she worked 15 hours, but we don't want to know how much she makes in 15 hours. We want to know how much she makes in 1 hour. So how do I get from 15 to 1? Very good. So we're going to divide by 15 denominator. Whatever I do the denominator, half is the numerator. So we're making equivalent fractions. Yes, Anna?
Your camera is like really off.
Yeah, I was about to say that.
Oh, it moved over.
Brady, it's your fault. You pushed the desk.
Sorry, friends.
Oh, did I? Oh.
Brady, that's your job.
I didn't even realize. I'm sorry. I'm not good with electronics.
Okay, so Bob said $9.15. So who makes the most?
I'm a bad boy.
Jennifer. Well, all of them would be Nathan.
Yeah. Dan makes $8.75. Nathan makes $9.25. And Jennifer made $9.15. Okay? So, Nathan makes the most money. Maybe he's the manager. Maybe he's been working there longer, right? We don't know the backstory. We don't need the backstory. We just know that Nathan makes more money.
He had a promotion last month.
He did? Did he save a life? And now he's good.
Yeah, just save your life from the next thing you know.
Yeah.
All right,
He just
so
saves a 300-pound woman.
Brian agrees to watch his neighbor's dogs for 7 days. His neighbors provided a 128-ounce bag of dog food. Does Brian have enough food to feed the dogs all 7 days?
No.
Okay. Now, what do you notice about Buster?
He's a little boy.
He's a big boy.
No.
Buster?
That's 2 days.
Okay. Great. Thank you for size comparisons. What do you notice about Buster?
He's
Buster
bigger.
got 2 days.
Buster.
He eats 20 Buster hits the gym.
Very good. He makes 20 and a half. He eats 20 and a half ounces in 2 days. Roxy, little girl, she eats 22 and a half ounces in 3 days. Are these ratios or rates equivalent?
No.
No, they're not. Okay, we don't know. We can't add them together and say, oh, we need this much food for this day. So we have to go back to home base. What's home base, Tucker? Shh. What's home base? I heard it. 1. 1 is home base. Your unit rate is always home base. So, for Buster, how much food does Buster eat in 1 day?
So if it's 5 divided by 2,
10.25 ounces.
Okay?
10.25.
Roxy sort of looks like a grandma's dog.
Yeah, I feel
Okay.
like Roxy and Buster.
Now, what about Roxy?
Roxanne.
Okay, so Roxy, 22.5 ounces
7.5.
in 3 days. Okay, we wouldn't know how much Roxy eats in 1 day.
7.5 ounces.
7.5 ounces?
Yes.
Agreed?
Yes. Buster is a giant.
Okay. Now, could we get from 2 to 7 easily? No. 2 is not a factor of 7. 2 is not a multiple of 7, so no, we can't. Okay? Can we get from 3 to 7 easily? No. So that's why we need to get back to 1 day. Because we're not just interested in 1 day, we're interested in
7.
we're interested in 7 days.
So if we do 10.25
Okay, how do I get from 1 to 7? Multiply by? Very good. Okay, so 10 and 25/100
71.
times 7. Okay, so 71 and 75/100 ounces in 7 days for Buster. And then Roxy,
52.5.
very good. How do I know if they left us enough dog food?
Because you gotta add them.
Very good. We need to add them together. So 52.5 plus 71.75.
It's not enough. There's no way. 25.
Yes, there is enough to make sense.
No, it's not.
Yeah, there is. You have 128.
Tell me more. I decided there's not more. So I ate the rest.
Okay, so this is called finding the unit rate. This is called scaling. Because when we are trying to find a value that's greater than what we have, we need to scale up. We had to scale up to 7 in this situation. And that's what we did. Okay, so here's what we're going to do tonight. You are going to do page 89. Okay, so page 89, and I want you to do 7 through 9. That's okay. So that's 4 problems. 7, 8, oh.
Easy, easy.
Oh, 3 problems.
But easy.
Yeah.
7, 8, 9. That sounds easy. I don't even know who I am.
Okay, I am not going to be here tomorrow. Okay, I have a doctor's appointment. And I have to go get some tests done, so I'm not going to be here tomorrow.
Is Kish gonna be here?
No, I think it's Mrs. Fedor. Okay, shh.